Hi, I'm Alan Ross. Welcome to another Take Five. Our guest today is someone that I met sitting across a table we were in some San Antonio, weren't we,
San
Texas?
Antonio, that's right.
San
Yep.
Antonio. At a conference. And when Nita told me that he was an electrical design engineer for SPX, I thought, no way, you're in college, dude. Now, he is smarter and older than he looks. He's always going to look like this. And for those of you who know, he's got that Dick Clark thing going on, a man who turned 90 and still looked like he was 21. But
Well, let's hope
welcome.
so.
It's good to have you.
Hey, thanks for having me. I really appreciate it.
So in the Take Fives, we ask one question. And by the way, Curtis also wrote a brilliant article within Transformer Technology, and it was on his generation of design. I mean, what are the things that he has to look at? So if you want to look up Transformer Technology, Curtus Duff, you will see his article featured. And it's a great one that when you look at the next generation. Ladies and gentlemen, we're looking at the generations. I'm the generation that's passing on the torch to the next generation. And Curtis, you are the one that's gathering that torch, and you're well equipped to do it. But we asked Curtis this question. What design changes have you seen in your career that you're actually applying in electrical system technology, transformer technology, because that's the area of expertise you work in, that you think are having the most significant impact in the marketplace for safety or reliability?
Sure. I really think that there's been a large improvement in really the materials that are being used in transformers. So a few that you can think of are higher grade core steels. So this is giving a customer lower no load losses. You've got high temperature insulation. So this gives the customer either the option of taking a transformer that could have potentially a higher MVA loading, or they could run it at a loading that it would be the same as another transformer that didn't have high temperature insulation, and you would expect it to have a longer lifespan.
Okay.
Another option is really like all the insulating fluids that are coming out. So there's the natural esters and synthetics. These give the opportunity for, as you were asking, for safety. They could potentially have higher flash points. So if a customer is concerned about fire safety, then maybe natural ester could be useful for them. Or if their transformer is going to be in a location where they're environmentally concerned, then those fluids could help resolve, I guess, some of those concerns for environmental hazards.
Yeah. One of the things I'm thinking, I'm a purchasing person, procurement, and
Okay.
the engineers come to me and they say, hey, we're building a substation and here's what we require. And I'm the procurement guy. I got to put it into specs and scopes. Most of the time, they do not, what you just did, you said, hey, this is for someone who wants that. For someone who wants safety, you might go to a
Sure.
natural ester. For someone
Hmm.
that wants, for instance, longevity, you're going to run it at a certain rating, but you want it to last longer. Or I'm going to run it at a higher rating, which tends to be what we do with transformers today,
Yeah.
especially in the utility industry. And
Sure.
that's true industrial too. They're all running for some period of time longer than they were supposed to, above
Right.
rating, wondering why the 32-year-old beast fails. So when you talk about doing these things, you're not talking about just making it better today. You're talking about making it better 20 years from now if these transformers
Absolutely.
last.
Yeah.
Okay.
Potentially making it last longer, which is obviously good for the customer.
Yeah. So let me ask you a question about that. Transformers, the average power transformer is 30 some odd years old, arguably 35, 38. They keep adding new ones, so it keeps changing. But
Right.
do you think the new generation with these changes, so better core steel, better insulation, better fluids, do you think the new generation of transformers are built as robustly as those 38 years ago?
In my opinion, I think they are. I feel like some people might have the feeling that they're not, but with the another improvement that contributes to this would be really that we have better calculation software. So
Mm,
that software allows us to really have improved transformer modeling, and with the increased computational speeds, we can really get a cost-effective design for a customer without really impacting the reliability. And then with these, also using these new materials, that's further going to extend the life of transformer, in my opinion.
That's excellent. No, we'll check you out 20 years from now and see the transformer that's got a 20-year life and it's worked into the 30 years. We'll come back and say you heard it first on the Take 5. But this has been a Take 5 with Curtus Duff. He's an electrical design engineer with SPX and a vital member of our next generation of people who are going to change the way things are done. But thank you for joining us, Curtus. It's been great.
Thank you very much. I really appreciate it.
Okay.